any source of light, let it be a hot piece of iron or a heated metal piece of copper or any other source of light, then the radiation coming out of that source, if they are passed through a prism, and then we try to obtain those radiations after the prism on a photographic film, then it is known as a spectrum of light. The pattern that we get on the film is called as the spectrum of light, and the spectrum is actually divided into two types. Firstly, based on the nature of the light which we used, the nature of the source of light that is used, and second is based on the origin. If we talk about the categorization based on the nature of light used, we get two types of spectrum. One is continuous spectrum, the other is discrete spectrum. What is a continuous spectrum? Wherein the spectrum that you obtain, it contains a continuity of all the radiations, continuity of light. Like for example, in the rainbow, what you see, one color is actually merging into the other, so that is a continuous type of spectrum. In Vibgyor that we get is the continuous spectrum. In this type of spectrum, it is always obtained when the white light is used as a source. Why? Because white light consists of all types of wavelengths. On the other hand, a discrete spectrum actually is a spectrum wherein it is obtained when the source of light is not made up of all infinite frequencies, as was the case of continuous spectrum. So if we talk about continuous spectrum, it is obtained when the source of light is made up of all infinite frequencies, whereas a discrete spectrum is obtained when the source of light is not made up of all infinite frequencies. So in that case, we can get a band spectrum like the colored bands we obtain, or we can get the spectrum in the form of fine lines, which is called as the line spectrum. Remember, the molecular spectrum will always be a band spectrum. Why? Because energy levels of the molecules are close to one another, they combine to form a band. Whereas the line spectrum is obtained when the electric discharge is passed through a gas or discharge tube. There what happens, the electrons in that case, they jump from the higher energy level to the lower energy level, or the emitting photons. Atomic spectrum will always be a line spectrum, whereas the molecular spectrum will always be a band spectrum. The other type of spectrum is based on the origin. From where is the spectrum originating? What is the cause of this spectrum which is leading to the form of the spectrum? One is the absorption spectrum, wherein the absorption of the radiation is taking place, and then the spectrum is obtained. The electrons, they jump from the lower energy level to the higher energy level, and that we get in the form of a spectrum. And the second type based on the origin is the emission spectrum, which is obtained when the electron jumps from the higher energy level to the lower energy level, and in that course of jumping, extra energy is emitted in the form of radiation, which we obtain as the emission spectrum. For absorption spectrum, white light is taken as a source of light because it contains all wavelength, and hence the substance can absorb the required radiation or the required photon or the frequency from it. Dark lines are obtained in continuous spectrum. About the emission spectrum, it was actually Bohr who studied the emission spectrum, and accordingly he gave us the Bohr's atomic model. We study the Bohr's atomic model. This model is actually applicable only to those species which contain one electron, or in other words, single electron species, like for example hydrogen, or He plus, or Li plus 2, Be plus 3, boron plus 4, or Na plus 10, and so on. So it can be an ion or a neutral atom which contains one electron only. Next is, it is considered that the nucleus is stationary. So all the studies that he made and all the conclusions that he came to actually are having one concept at the back, that the nucleus is stationary. Bohr actually thought about the 2D model of the atom. So if you look at this figure, this is actually a depiction of an atom. In the center you can see green and yellow spherical structures which act actually are the protons and neutrons inside the nucleus. So that much portion of this entire atom is actually the nucleus, and outside this nucleus you can see 3 rings. All the 3 rings contain one spherical red colored structure. So these rings are actually shells around the nucleus in which the electrons are moving. If we consider the charge on the nucleus, which is basically due to the protons present in the nucleus, so the total charge will be Ze. Z stands for the atomic number of that particular species. If it is hydrogen, so Z is 1 over here. If it is helium, Z will be 2 over here, and so on. And the distance from the nucleus to the shell wherein the electron is sitting, that is the r, or the radius of the atom. And we see here that the electron is continuously moving with a velocity v. So considering this model, if you apply a bit of physics over here, you can say when the electron is in continuous motion, circular motion, so the centripetal force actually is getting balanced by the Coulombic force due to the protons in the nucleus. This is the reason why the electron doesn't jumps out of this particular shell, out of the atom. So these forces are balancing each other. That means mathematically you can write mv square over r, which is the centripetal force, which is equal to Coulombic force, that is k q1 q2 over r square, where q1 q2 are the charges of these species, protons and electrons. Now, before moving further, we should know the postulates of the Bohr's atomic model. So accordingly, out of infinite possible orbits, out of all the infinite possible orbits which might be present in an atom, it is said that electron is possibly only in those circular orbits for which its angular momentum is integral multiple of h upon 2 pi. So angular momentum is what? mvr, which is equal to nh over 2 pi, where n is the shell number, h is the Planck's constant, r is the radius of the orbit. So one of the postulates of the Bohr atomic model is that out of all infinite number of orbitals which are existing in that particular atom, actually electron is found in that particular orbital wherein the angular momentum of the electron is integral multiple of h upon 2 pi. That means it should contain that much amount of energy. Second is that the concept of energy orbit was actually given by the Bohr. So in other words, it is also called as the stationary orbit. Means every orbit has fixed amount of energy, and Bohr called them as he labeled them as k, l, m, n, and so on. Outside the nucleus, infinite orbits are possible, which is named as k, l, m, n. Now, the energy of k orbital is fixed. Likewise, the energy of l orbital is also fixed. So, in short, we can say that the energy of all these k, l, m, n orbits are actually fixed. So, the electron can absorb energy. When we say the energy is fixed of that particular orbit, that means the electron can absorb energy and can be excited to a higher energy level when it returns to the ground state. That means the least energy state, energy is released in the form of quantum. This is as per the Bohr model. Due to this process, when the electrons jump from the higher to the lower energy level, during this process the excess amount of energy is given out, which if we observe on the photographic plate, that means when these radiations or when these photons they strike the photographic plate, we get a spectrum, and that in other words we get the spectral line. Now what we can conclude is mv square over r is equal to k ze square over r square, and as per Bohr, mvr is equal to nh upon 2 pi. That means angular momentum of electron is quantized because the electron actually exists in certain orbits which carry a fixed amount of energy. So Bohr was actually the first one to use the concept of quantization to explain the atomic model. Before Bohr, none of the scientists actually came to the quantization of atomic orbitals. So according to Bohr, the energy carried by these orbitals is actually quantized. It is an integral multiple. So from these equations, that is mv square upon r is equal to k q1 q2 over r square and mvr equals to nh upon 2 pi, we can get the value of velocity, we can get the value of the radius of orbital, as well as we can also get the total kinetic energy, potential energy, and the total energy. So from these two expressions we get r is equal to 0.529 n square upon z, where n is the number of orbital and z is the atomic number of that particular species. From this, the radius of that particular orbital wherein the electron is being talked about comes out to be in angstrom. Similarly, velocity expression we get 2.18 into 10 is per 6 z upon n, wherein v is in velocity is in meter per second. So this is the velocity in the nth orbital. Likewise, total energy, if we are trying to calculate, we get the expression minus 13.6 z square upon n square, and this will be the value of energy in electron volts per atom. If we want to calculate in joules per atom, we get 2.18 into 10 is per minus 19 with the minus sign into z square upon n square. The total energy was minus 13.6 z square upon n square electron volt per atom. So the kinetic energy will be plus 13.6 z square upon n square electron volt per atom. Likewise, potential energy will be minus 27.2 z square n square electron volt per atom. Now to calculate the time is equal to distance upon speed. That means the circumference circular path which the electron is moving. So 2 pi r upon v. Substituting the value of v over here, we get time is equal to 1.52 into 10 is per minus 16 n cube over z square in seconds. Now from this expression you can know that the time is proportional to the cube of n, the number of orbit in which the electron is there. So cube of it and inversely proportional to the square of atomic number of the element. In our next video, we will discuss about the line spectrum and the energy profile diagram of hydrogen-like species, wherein we will discuss about the Lyman series, Brackett series, Paston series, and so on. So stay connected.